Okay, welcome to I Square Maths Academy, where numbers meet mastery. Today we are going to be looking at another section of differentiation using the quotient rule. In our last class, we actually looked at differentiation using the product rule. And of course, we know when we say product, product means multiplication, while quotient means division. So it therefore implies that for quotient of functions, we have y is equal to u all over v. U divided by v. Now, u and v are both functions of x. Yes, u and v are both functions of x. Now, in this case, y is the dependence, while u and v are the independent variables. So it therefore means that a change in y plus delta y will be equal to u plus delta u all over v plus delta v. Yes, y plus delta y is equal to u plus delta u all over v plus delta v. Now let's look at y plus delta y minus y. It means here we'll have it as u plus delta u all over v plus delta v minus. Now remember here we said y is equal to u all over v. So since we are subtracting y from the left hand side, it means here we are subtracting u all over v from the right hand side. So it means here y minus y will be left with delta y. So delta y will be equal to u plus delta u all over v plus delta v minus u all over v. Now let's look at the LCM of v and v plus delta v. That will give us v in bracket v plus delta v. Yes. Now v plus delta v into v in bracket v plus delta v will give us v. Yes, this into this will give us v. And v times u plus delta u will be v in bracket u plus delta u minus v into this will give us this. That's v plus delta v times u. We have u in bracket v plus delta v. So it therefore means that delta y will be equal to v in brackets u plus delta u minus u in brackets v plus delta v all over. When you expand this, we have v square plus, because v times v is v square, and v times delta v is v delta v. Now, delta y will be equal to, expanding this, we have v times u, that's uv, plus v times delta u is v delta u, minus u times v is uv, minus times plus is minus, u times delta v is u delta v, all over, here we have v square plus v delta v. Okay, now looking at this now, uv will go with this uv. We'll be left with delta y will be equal to v delta u minus u delta v divided by v squared plus v delta v. Now let's look at change in y all over change in x. It is delta y all over delta x. This will be equal to v delta u all over delta x minus u delta v all over delta x all over, we have v squared plus v delta v. Now it therefore implies that as delta x tends to 0, delta u tends to 0, delta v tends to 0, delta y all over delta x will limit itself to the y all over the x. Delta u all over delta x will limit itself to the u all over the x, and delta v all over delta x will limit itself to the v all over dx. So therefore, the y all over the all over the x will be equal to, here we have v. Now this delta u all over delta x will reduce, will limit itself to the u all over the x. Here we have minus u. This delta v all over delta x will limit itself to the v all over the x, divide by, here we have v squared plus, now remember we said as delta x tends to 0, delta u tends to 0, delta v also tends to 0. So it means those delta v here, we'll have it as v in bracket 0 because delta v will also tend to 0. So the y all over the x, will be equal to v du all over the x minus u the v all over the x divided by v squared plus, here we have v times 0 is 0. So the y all over the x, the y dx will be equal to v the u all over the x minus u the v all over the x divided by v squared. Now this is called the quotient rule. Yes, this is called the quotient rule. So it therefore means that if y is equal to u all over v, the y all over the x will be equal to v, the u all over the x minus u, the v all over the x. Now we're going to look at one example using the quotient rule. Now, example one. If y is equal to sine x all over cos x, find the y all over the x. And we all know that from trigonometry, sine x all over cos x is the same thing as tan x. Yes, tan x is sine x all over cos x. So here now is like asking us to differentiate tan x. Now in this case, our u, say let u be equal to sine x and v be equal to cos x. If u is equal to sine x and v equal to cos x, now let's see the u all over the x. The u all over the x, when you differentiate sine x, it gives cos x. And the v all over the x, when you differentiate cos x, it gives minus sine x. I take it again. When you differentiate sine x, it gives cos x. And when you differentiate cos x, it gives minus sine x. Now, applying this rule, that the y all over the x is equal to v the u all over the x minus u the v all over the x divided by v squared. It means the y all over the x will be equal to, now the first thing to pick here is v. Yes, because we have v the u all over the x. And we know the value of our v is cos x. So it means here we pick cos x. Cos x. Then now let's see the u all over the x. The u all over the x is also cos x. So here we have cos x. Then here we have minus. You pick the value of u. Our u is sine x. So you pick sine x. Then the v all over the x. The v all over the x is minus sine x. So here we have minus sine x all over v squared. And remember we said the value of v is cos x. So it becomes cos x all squared. So therefore, the y all over the x will be equal to cos x times cos x is cos square x. Minus times minus is plus. Sine x times sine x is sine squared x. Divide by cos x squared is cos squared x. Yes, cos x squared is the same thing as cos x times another cos x. and that will give us cos square x. And we know from trigonometric identity, yes, trigonometric identity, yes, from trigonometric identity, we say sine square x plus cos square x must be equal to 1, irrespective of the magnitude of the angle x or theta, as the case may be. Sine square 1 billion plus cos square 1 billion is equal to 1. Yes, so it therefore means that the y all over the x will be equal to cos square x plus sine square x is 1. So we have 1 all over cos square x. And of course, you know 1 over cos x is sec x. So it means 1 all over cos square x will give us sec square x. And that's why we said if y is equal to tan x, that the y all over the x will be equal to sec square x. Now, this is actually, this is the end of this, the solution to this. So if y is equal to sine x all over cos x, the y dx will give us sec square x. And we know that sec x, sine x over cos x is the same as tan x. So when you differentiate tan x, it gives sec square x. Watch out for more examples. Thank you for listening.